Hello everyone! In this video I would like to show you how I built this 1.5 kWh lithium iron phosphate battery. I used this ammo can to hold all the cells in it, and also put here some power meter to show me what's happening of the battery, the state of charge, what is the discharge level and charge level of the battery. It features 1.5 kilowatt of batteries, also 300 watts onboard charger, active balancer on the cells, which is capable of doing 1.2 amps of balancing, two USB ports that can charge up to 1.2 amps, 1 kilowatt power continue output, over charge protection, over discharge protection, short circuit protection, and also each individual cell protection. You can use the battery also to charge, for example, electric vehicle. You can see now I am charging with around 1 kilowatt. I'm draining 92 amps from the battery, and I'm charging my car. This is, I think, the maximum that you can retrieve from the battery. I made a video about that, so I will put a link in the video description how I charge my car with this battery. You can charge any USB device with these two outlets here. Whenever I press the button, you will see that the battery is charging. So any USB device can be charged from this battery here. You can charge also with solar panels. Each of these panels are 10 watts solar panel, and they are made to charge lead acid batteries. And when I plug here the positive, you can see that I'm charging with around 16 watts. The way I prefer to charge the battery is to use this converter here with the power supply here. So when I press the power switch here, you can see that it is charging. Let me show you this. It is charging with around 300 watts. I intentionally reduce the power so that I don't stress up this converter and not generate much heat. I intentionally didn't put outlet from here somewhere to the ammo box, because it is best to charge it open like this. This converter and the power supply can generate some heat, so this heat needs to go to the air, so I prefer to charge it open like this. This is the noise that you will hear whenever the fan of the power supply unit start to dissipate heat. It is quite a powerful fan, so you can expect some noise here. The setup is as following. We have 4 lithium iron phosphate cells, which are connected in series to create one big 12-volt battery. On the bottom, here on the bottom, is the BMS, which is 20 amp BMS. The leads from the BMS are coming from here, and then they go all to each of the cell. Then from the BMS, this is the battery minus, which is connected to the minus of the battery, and the other side, the power of the BMS, is connected here on the shunt. Let me show you the shunt. This is the shunt. The shunt is the other side of the shunt is the negative pole of the whole battery. It goes to this negative pole here, it goes to the this converter, and it goes to this USB outlet here. And when I press here the button, you will see that it's working. Okay, the battery plus terminal is going to the plus terminal here, and it goes also to the this converter and to the USB, of course, here. What else? We have active balancer here mounted on the top to balance the cells, because the battery, the BMS balancer, is very low in power. It can power with 60 milliamps. This can balance with 1.2 amps. For the charging circle, we have power supply unit from the server, which is 460 watts. That is coming to the DC-to-DC converter here, which is constant current, constant voltage boost converter, which boosts the voltage from 12 volt to 14.4 volts. And then it's going to the battery. This is all the materials that I will use for the build. These are the cells that will be in our battery. This will be the power supply that will charge actually the batteries. It is a server power supply which is able to deliver 38 amps in 12 volts. And I modified it to run without the server when I put a jumper from the first pin and the fourth pin. This way it doesn't require a server to be plugged in to work. So I'll use this for the charging of the battery, but actually I cannot use this single alone. I need some kind of constant voltage, constant current DC power supply, so that's why I will use this one. This is able to deliver 1.8 kilowatts, so that's pretty high. It can be constant current, constant voltage with this potentiometer here. You can set up what's the voltage, what's the current, and this way I will set up the voltage to be constant 14.8 volts, and the amperage will be, let's say, around 30 amps. So I will use this one. For the information what's happening with the battery, I will use this power meter. This is a shunt. It's rated for 20 amps, so it's enough for our battery. And this will show me actually what's happening with the battery, what's the power consumption or power charge. So I will use this one. For the balancing, I will use an active balancer like this. I will use this one. This is rated for 7 cells, but actually you can use it for whatever cells you want, from 1 to 7. So I will use this with my 4 cells. I will use the active balancer because the BMS can balance the batteries only with 60 milliamps, which is quite slow. This can handle 1.2 amps, so that's pretty good. And also it's active. This means that it's balancing the cells whenever there is a difference in the voltage. But the BMS actually, which is already in the box, can balance only when the cells reach 4.2 volts. What else? I will try to put USB if I can, if I find some spot in this small box. We will see. And what else? This is the BMS. It's already mounted. So I will show you how I mounted it. As you can see, I have already put some screws on the bottom of the ammo box, but I used this as a template. The BMS comes with these 2 strips like this, metal planks, that you can mount the BMS to some surface, and I use them for a template. You can see here that these are the holes. I already drilled them and mounted them. Let me show you what measurements do we have. So we have 5.1 centimeters from one side and 24 from the same side. If you go like this, it's around 5.2 centimeters and 12.8 6 centimeters. So I hope you see it. Let me show you the measurement from this side. And actually this is how I mounted it. I drill some holes and I screw the BMS on the bottom of the ammo box. So this is the BMS. It's mounted but stable. After I mounted the BMS, now it's time to put the balance leads. I already soldered these holders to the end of the one of the end of the balance lead, and the next one will go to the BMS. So I will connect it like this, and then I will mount the batteries. I'll put the first cell, then put it all the way to the back. Then I'll put the next cell. Keep in mind that this is the positive, this is the negative. The next one should be on the opposite side. This is the negative, this is the positive. Okay. Then again flip them back. This is the positive, positive, negative, positive. And the last one. So you can see there is a lot of space here, but this space will be fully occupied with other electronics. So if you notice here, I have replaced the original screws with M6 bolts, which I cut because the original ones are very high, and there is a potential risk that it can short circuit the battery when I close the lid. That's why I took some. These are the bolts, actually M4 M6 bolts, 12 millimeters. And what I did is I took, this is the bolt original, and I cut it on half like this. Let me compare it like that. I cut it like that, and I left the positive, which I left two bolts a little bit higher for this mounting points here, so that they can be mounted and there is enough room, enough space to bolt the BMS. The next thing that I will mount on this pack is this converter. I will put it, this is the output, this is the input. I will put it like this. The output should be on the bottom, and I will mount it just here on the ammo box, so that the negative terminal can be put like that. The this converter is already mounted in the box, so the cable is here to connect the minus of the battery, and this will be the positive, actually not the positive, sorry, this will be the power lead, and I will mount here the shunt, which will help me to identify what is the power that is drained from the battery. I will mount like this, but before that I will make a hole here for the display. I have made the hole here. You can see I have put some isolation, rubber isolation to the hole here, because I just want this to be isolated. If you want to, you can skip this part, but the box actually is very well isolated. You can see here there is a rubber that sticks very well to this corner here, so I prefer everything to be isolated. The bad thing on this rubber band here is actually the cover. I didn't have green or black cover, but if you want, you can skip it. I put this for isolation purposes. So here I will put the meter, you can just, there's a clips here and here that it will clip to the hole, and I need to press it like this, and this will be the place for the display. And now let's mount the shunt. Actually, the shunt will be mounted here. I have already made some holes, so I will put a bolt here and we'll bolt it here. The space here is very tiny and small now, so it is hard to do most of the things. Here I will try to bolt the other one. For that purpose I will need a screwdriver, because here the place is really very small. Okay. Now you don't see it. Let me show you what I'm talking about. This is the first bolt here. And this is the second one here. I think it's ready. So this is the connection from the display to the shunt. So I will connect it like that. And now it is time to place the power supply unit. Now it is time for the power supply unit. I have isolated the bottom part with the Kapton tape, which is a tape that can do electrical and also thermal isolation. And here I have soldered XT60 connector. So I'm planning to mount the power supply unit like that and to bolt it here on the ammo box. It is on the edge, the hole here is on the edge. I'm also planning to charge the battery using AC but with open lid, because there is no space actually for okay. Let me now bolt it. The space is so tidy that there will be no room for anything actually. I'm also planning to put here on the top a fan, but that will be on a later stage. I need to test first to see what is the heat generated from this battery, how it dissipates the heat, stuff like that. For now I will not put any fan, but I'm planning to do it, so I have room to do the fan. If I want to, I can mount it here on the top of the box, here or here. So I need to connect both like this. Okay, this will be connected to the battery, this will be connected here, this will be connected here. What else do we need? We need the active balancer. So for that I will solder here the leads for the active balancer. I have soldered the active balancer terminal to the battery terminals here, and these leads actually will not be needed for now. Before I connect the active balancer, let me check what is the voltage of the cells. So the first cell is 3.29, the next 3.29, the next 3.29, next 3.29. So they're very well balanced. I don't think there will be no need for balancing. Let me connect the active balancer. So you see it finds something on the first cell and it will balance it. Okay, that will be the active balancer. What else I did? I also make a cable for the positive terminal, and I also drill 2 holes here for the positive and negative terminal of the battery. What else did I did off camera is to make these holes here. You see them on the bottom. The first one will be for the USB outlet here, like that, and the second one will be for this switch to turn on or off the USB switch. So I'll connect everything. Before that, check if what else I did. Yeah, there's one more thing that I did, and this is that I make one more cable on the positive that actually connects, this is the cable, connects to the shunt here on the back. This will be the positive of the shunt. So now let me check what will be the output of the power meter here. I'll connect it. And you can see that, let me just lower the camera. You can see that we have 13.17 volts and 48 amp hours left on the battery. In order to set this up, you need to be on amperage hour, not in the watt hour. So to go to amperage hour, you need to go to the upper arrow and then long press the OK button, and then you can set up what's your batteries, what is the state of charge of this voltage, and that's actually it. So I will connect everything together and we'll continue from there. Now everything is wired. I fixed the wires with the zip tie. Wires from here are coming from the BMS. They go to the power of the battery cells. And also I have the leads for the active balancer. I glue it to the cells here with double-sided tape. You can see here that the balancer is balancing the third cell. And if you go here, you see that currently I have 13.8 volts here on the battery. Also here on the USB, if you press the button, you can charge anything that is requiring a USB. It's 2.1 amps each of the USB outlet. What is left actually to do is to mount a fuse. I ordered a fuse 150 amps 1 month and a half ago, but I haven't received it. When I receive it, I will mount it here or here, I will see. But I need to mount this fuse, and also what I need to do is mount some isolation here, because it may have the opportunity, the batteries, to contact the metal here and make a spark. That's why I will put this kind of isolation, this paper isolation, that you need to remove the cover here and stick it to the lid of the ammo box, like this. Okay, Now when I close it, I will be sure that it won't have any short circuit on the bottom. And also you can see here that I have tuned the power meter here to turn off after 60 seconds. That's it for this video. I hope you like it. If you like it, give me a thumbs up. Don't forget to subscribe to my channel. See you soon.